Hello, my name is Susan Woodman and I'm the Manager for International at Oz IMM. Welcome to today's webinar on the future of mining. I'd like to start today by acknowledging the traditional custodians of the many lands on which we meet throughout Australasia and internationally. We recognise our First Nations people's strong connection to land, sea and community. I pay my respects to elders past, present and emerging. I'd like to thank everyone for attending our international webinar series for the Asia Pacific region and for those who may be watching this recorded webinar. Just a couple of housekeeping items before I hand over to our facilitator and panel. Everyone will be on mute today just to avoid presenter feedback and noise feedback as well. There will be time for questions at the end of the presentation, and should you want to ask any questions, you can type those into the chat box, which is available to you on the side of your panel. We'll also be sending a copy of the webinar to everybody via email to those people who have registered in the coming weeks. Now I'd like to introduce you to the facilitator of today's webinar series, and that is Serkan Saydam. Serkan has more than 250 publications and has graduated 18 PhD students to date in his career. He's currently serving as the Discipline Leader of Mining, Engineering and Research Director at the School of Minerals and Energy Resources Engineering at the University of New South Wales. He is a fellow member of the Australasian Institute of Mining and Metallurgy. Welcome, Serkan.
Thank you, Susan, and thanks to Oz IMM for the opportunity. And for almost a century, the technologies used in mining have been really incrementally improved to reach a higher production rates and therefore aiming to achieve better economic returns and safer and more environmentally friendly operations. Now everyone is talking about zero entry mines, which certainly requires synergistic interactions of humans and machinery. To achieve this, we certainly need to establish good communication in the extreme environment where we operate. Today, we will discuss the term evolved in the last couple of years named Mine Internet of Things, mainly referring adaptation of the communication technologies into mining operations. We will talk about mainly tomorrow and challenges and opportunities in the future. Now I'd like to introduce you to our expert panel from the Asia Pacific region. We have the esteemed panelists group. So Binghao, Senior Lecturer at the School of Minerals and Energy Resource Engineering at UNSW Sydney. Binghao is the leader of Mine IoT and IPIN Lab at the school at UNSW, and he has a Bachelor of Engineering, Electrical and Mechanical Engineering from Beijing Jiao Tong University, and also Master of Engineering in Civil Engineering in Tsinghua University. He also received his PhD from UNSW in Spatial Information Systems. His research areas include indoor positioning, pedestrian navigation, satellite positioning and navigation, and Mine Internet of Things. Hi, Binghao. Our second panelist, Rithin Payyanadan. He is the business lead, mining, materials, and chemical solution at Yokogawa. Ritz, we want to call Ritz, right? You know, you prefer this. Thank you. Ritz currently leads the solutions business in the mining and minerals processing at Yokogawa, Australia, as well as in New Zealand. Ritz comes from a background in control systems engineering with a focus on design, systems design, instrumentation, control systems, and business systems integration. He also possesses a business background with qualification in technology and innovation, as well as the product management. He worked in natural resources sector over 15 years in oil and gas and mineral processing, as well as utilities such as water and wastewater. Ritz is a strong proponent of the use of automation and digital transformation in enabling operations to become safer, resilient, sustainable, and profitable, and of leveraging lessons from other industries. Thank you, Ritz. And our third panelist, Rajiv Chandramohan, he's the technical director and global operations Osenko. Rajiv has extensive experience in mineral processing research, comminution, materials handling, metallurgical testing, and numerical and process simulations. He has developed a wide range of novel technologies applicable to the mining industry in gold, copper, platinum, and diamond operations. Rajiv is currently technical director at Global Operations and Osenko. He is assisting clients achieving full production potential through an integrated technology solutions. And he is currently joining us from Vancouver, Canada. And we got hi Rajiv, and Binghao and Rithin and myself are in Sydney. So it is really impossible to predict future if we don't look at the history. And I particularly enjoy looking at history because my focus future really future of mines. History tells us that communication technology has developed from transmission of information by the human body to simple signal communication, and then to wired communication and wireless communication now, which goes back to almost 19th century with the invention of telegram. And until most recently, invention of internet in 1960s, 80s, you know, when I say most recently, it's almost 40 years now, it's 40 years actually. And now we talk about 1G and 5G. I don't know, it's 6G, 7G, what's gonna happen like the iPhone branding. So I wanna start the question looking at the communication technologies. These technologies qualified for extreme environments. We operate in surface or underground workplaces. They are critical for monitoring operations remotely and also real time. The infrastructure and logistic requirements will be different in the future due to the perceived interactions of human and machinery, as mentioned, with tailoring technologies for increasing mobility and the availability in the mining operations. So I want to ask Rajiv first, what does a connected mining operation or what is connected worker mean for the future of mining?
Good evening or good afternoon or good morning to all. Thanks to my panelists. Second, yeah, I guess to answer your question, I think that we need to first look at the context of that question. So from a connected mining operation, it's a physical connection, as you point out in the context of this discussion. Instrumentation, sensors, I mean, we are fairly rapidly advancing on sensor technology, and like 5G is a medium to connect various systems very quickly and transfer large volumes of data. From my perspective, when I'm looking at from an operations point of view, what do you do with this data? So a connected system needs to talk to, okay, from a mining operations perspective, resource definition, what's in the ground, and how are we going to use that knowledge to make predictions or performance predictions rather, how the plant's going to perform. And in order to have that decision driver, you need to have good instrumentation or data in the essence. So there are two parts to that question. Perhaps Rithin can further elaborate on that, the connected part of instrumentation from Yokogawa's perspective. But yeah, I'm mainly focusing on what do we do with this data from a connected minds perspective. And the future is, now we want to make operations safer. So in order to make operations safer, you need to have sensors where you can remove the operator from the mine. Okay, so once you have that, then what do you do with that data? Because ultimately the operator is making the decisions to add value to the mining business, because at the end of the day, how much gold am I going to produce? And what is my constraint? So that system, whatever system we're talking about in a connect, it needs to make that decision on behalf of the operator. Now that you remove that operator from so call it the danger zone. So that's my sort of in a nutshell what a connected operation should be.
Yeah, I mean, we will dig this a little bit more in the how can we use the data a little bit later in the next other questions. So Rithin, what do you think? Do you think the technology is ready? And Binghao, I will ask the same question to you as well.
Sure. Thanks, Serkan, and the panelists for having me here today. So Rajiv touched on exactly the point. is what, when you're designing a system, you have to understand what do you want it to do, right? Are you just collecting data? So IoT typically, I'm going to use a very simple analogy. I'm going to dumb it down a bit. So in your home, you have a smoke detector, right? Now that device, is, let's say, mission critical. So as a result, if it's sensing, it needs to do the calculation within itself, an alarm within itself. You cannot afford it to collect the data, send it out to the cloud, make the assessment if there's a smoke, and then send it back. If there's any failure points in that loop, it will not serve its purpose. So for mission critical things, there is a strong push to drive it to the edge, right? For non-mission critical, let's say you have, you're a smart gardener and you're putting some sensors to get the soil quality, water and so on and so forth. Now, if they're not mission critical, they're just collecting data, putting it in a data lake, running some analysis, and then later on, if it's controlling your sprinkler system, that is non-mission critical. And that's where you can say, look, I'm happy to have a low latency network, as in the data can go there once in 10 minutes. I don't care. The soil quality is not going to change at that pace, right? Water leaching, fertilizer leaching. So when you're designing, IoT is Internet of Things, like Rajiv said. It is letting machines talk to each other so that you can make a better decision, or you can make more informed decisions. You have to start thinking about basics of system design. What is the challenge? And then that determines the choice of technology, the choice of networks, communication technology, so on and so forth. So long answer to your question, Serkan, today I think technology is coming there. I mean, like 5G is brilliant, right? It is a low latency, high bandwidth type network with security, so on and so forth. But you also have to ask about, what about GPS? Autonomous vehicles rely more on GPS. So does that work underground? So in general, today is much better than 10 years ago. I can say that, and we're very happy. But there are principles of design which we can use to fill the gaps, in technology. We've always done that as an industry, So if you design systems and networks properly and use certain networks for certain functions, I think we can get to where we want to, if that answers your question.
Yeah, thank you, Ritz, spot on. So Binghao, same question, but you will certainly answer as researcher, because you are using the technology as well as developing the technology.
Yeah, thanks, Serkan. Thanks, everybody. My answer will be slightly different. My answer is it's not ready yet. We are still on the track, on the way. But the technology is good enough for many applications. For instance, now we can locate the worker and the machine very accurately on the surface using differential GPS or real-time kinematic to achieve centimeter level accuracy. But underground, we can, not everywhere, we can achieve up to 10 to 20 centimeters in some areas. And for, say, monitoring purpose, we can monitor the environment, the change of the environment quite accurately, but not everywhere, some key areas in near real time. So my answer in summary is we are on the way, not 100% ready yet, but we'll be there.
Yeah, that's definitely surface and underground, different environment, different extremes. I mean, Rajiv and Ritz have experience in processing plants as well. So that's also considered surface, but have different challenges, right? So we'll touch this a little bit later as well. So while we're talking about the challenges, Binghao, perhaps you continue about challenges on IoT technologies in mining operations, but think about the future fully automated mines, fully connected mines.
Yeah, in about 2.5 years ago, we prepared a report for an industry partner discussing about the AI and IoT application in mining industry. At that time, we summarized several points. It's about change a little bit now, but still, I think most of the points are valid. I summarized like that. So the first thing is a low power and a small size wireless smart sensors and devices. And the second thing is a power source. Now we can say surface, we can use solar power, but in underground, and other extreme environment. So we have to think about other sources. Battery is not a perfect solution. So we may use, say, vibration energy harvesting or this energy harvesting technology. And the third thing is it's about the network and data security. At this stage, maybe it's not a big issue yet, but in the future, it will be a big issue. And the next thing is standards for mine IoT. And this is a big topic. And I don't think we put much attention on that area yet. The fifth thing is the unified high capacity, low delay communication network. 5G has a potential. So 5G, we're still developing 5G, and we haven't completely used it in mining industry yet. Underground localization and navigation is a big issue. For surface, it's easy. Underground is extremely difficult. And for emergency communication, say after disaster, so what can we do? And the last thing is the gaps between the theory and the application. So that's probably this thing summarized a lot of things of the challenges.
Yeah. Thank you, Binghao. And Rajiv, what do you think about the challenges? Can you add more into that?
Well, I look at it from a perspective of what do we want to use the system? So are we going to trust the IoT system or sensors to control? There are two parts to it. So control systems need to have redundancy or say fail-safe, as you know, Rithin pointed out there as an example of smoke detector. So it's a mission critical sensor. It has a specific purpose, but would you use an IoT or 5G connected sensor to do that task? Because if it's going to rely on a battery, then you know it's not a reliable system, as you know, Binghao pointed out. So there are two parts to it. So communication is important. What are we going to do with it? That's the decision part, which all these sensors are going to provide to the user. But from a control perspective, you're still going to be, in most cases, it's going to be hardwired, connect to a power source. It's going to have redundancy. So it's we need to think about the communication part carefully. What in the context of big data or in IoT systems.
I think, Rajiv, you talk about interoperability, right? This word started really entering the mining industry big. So how we can achieve the data collaboration. So Ritz, what do you think about the challenges? Is there any left, or you want to highlight a couple of others?
No. Binghao touched everything in great order. I guess my personal few would be, I'd probably say three. One is interoperability and lack of standard. That's a great topic. No one touches on that much, and there's a reason. Now I'm going to be a bit transparent. So as OEMs, Yokogawa is an OEM. As OEMs, you try to and industry tries to come up with something so that they get market share and they become a market leader in it. However, now I think with Industry 4.0, everyone realizes that you cannot not be interoperable, right? So interoperability is key, and Yokogawa spent probably the last, our heritage of control systems, distributed control system, that term was coined by Yokogawa in 1975. Basically, it's sending the control out so there's no central point of failure. So today our biggest focus is on interoperability, a non-agnostic platform that can integrate with multiple systems, be it an autonomous vehicle, let's say a smart ventilation system underground, right? So the different technologies, but you have to establish a few open standards. So OPC UA is a standard, OPC Unified Architecture, right? They are trying to, the OPC organizations try to push that down, saying it would be advantageous if every vendor can be on that platform. What that enables is a unified platform to pull technology. So definitely challenges in adoption and running with it is interoperability, right? For example, Apple won't let you. I was looking to buy a Samsung watch just because I like it, and I just found out that the latest Samsung watch cannot work with Apple. They said cannot. You cannot even download the app for it. Now, these sort of things is what probably will delay technology adoption. So interoperability and standards definitely. Cybersecurity is key. So that'll be the second one I'll touch on, right? We are not there yet, and mining has recently taken it more seriously than, again, we work in oil and gas and utilities. Over there, cybersecurity has been like way strong since the early 2000s. I can see it coming into mining right now, but I think there's a lot of education to be done.
Why is that, Rithin? And why is there a delay in the mining industry for adopting what's already been done in the oil and gas industry?
Look, I can't comment on behalf of the industry, but I think it's the fact that, look, it's a fact that consequence, risk assessment, right? Consequence and probability of occurring. These are the two things. So when we sit, we do safety system design. When we sit and do a safety system design, what's the probability of this failure occurring, and if it occurs, what's the consequence? In oil and gas, someone breaching the system, taking control of an oil and gas facility, literally, it's a national security issue. Like they can explode, the plant can explode. All right. So the consequence of a cyber threat was much more higher seen in oil and gas as compared to mining. However, now, I mean, was it Roy Hill? I think they're running a completely autonomous fleet. They have autonomous trains. Now, someone taking control of an autonomous train, it's you can say borderline. It's getting to that critical issue. You can, a terrorist organization can take control and ram it into thousands of, billions of dollars of infrastructure. So I think that's that gap, Rajiv. Is the perceived consequence is not that big. They're like, what's the consequence? What's the most that could happen, right? But I think now that has changed. Now, most of the people we have dealings with is a CTO. The title is going to be Chief Technology Officer, Chief Information Security Officer. So we're starting to see these roles in mining CX levels, and they're dead serious about it as that IT/OT piece, right? So even though the OT team might take it a bit lightly, I can see that the IT team will push it down. So it's good, right? I think you need it. If you want to go autonomous, you need to have cybersecurity, 100%.
Look, I guess, Rajiv, answering your question, I mean, I asked questions, but you can feel free to ask questions as well. It was great. So I think miners like to be first to be second. There's a proverb on that. So I think that's the reason. So mining companies waiting some other companies, mining companies to first try. I think that was the biggest issue in the whole industry. So we can dig this out a little bit more if necessary, but I want to remind you one other challenge which is in my notes about skill shortage. So do you think that, I'm looking at, I just read your bios, all three of you have very multidisciplinary, you've been trained very multidisciplinarily, except me. I'm only mining engineer. I've been trained as mining engineer. All my degrees are mining, but you three are very mixed. So where do you see this skill shortage in specifically for the communication technologies? So any comment on this? Any of you, please?
I can start with that. So COVID, for example, it has truly tested our communication systems, right? The mining industry didn't stop. Maybe for a brief moment, everyone sort of huddled into a corner, but when things opened up, it rapidly opened up. But given that we could not travel, we still need to provide a service and consulting solutions. It really forced us to think differently. I cannot jump on a plane and travel to a remote mine site. So I have to work with the systems, whatever systems are existing at a mine site, to remotely connect to it and work with the client to identify the issues. And it's changing. I mean, this is what the future is going to be. And I'm working from home for the last 2 years. I've got guys in my team working from home as well. It's changing the way we are providing a service. At the same time, it's also an advantage because you are not restricted to bring in the best team to provide a solution. You can find experts who can still provide solutions. You don't need to hire them because now they can work remotely and still remotely diagnose. For example, I read somewhere people are at mine sites starting to use these head visors with a camera system to it. So the team at site, they have the solution. You as an expert, you can remotely have a Teams call, and you can see what they're seeing, and you can give guidance. Oh, okay, this is what the setting you need to change. And so firstly, it's enabling or upskilling the workforce, and secondly, you don't really need to be at site. You can look at multiple sites at the same time. So it's a great benefit.
Yeah. So what do you think, Ritz, Binghao? Any comments on the skills shortage or improvements required?
Yeah, so if I can, so I guess, look, complementing what Rajiv said, I think there was an issue with skills shortage, I mean, both in being able to hire young people to go and work in remote mines. I think I read somewhere that was being a challenge, a number of students going through mining school and developing their core skills. I believe that now with remote technology, that can be mitigated a bit. I mean, you can get, I guess, urban people to work, like Rajiv said, experts can be all over the world. So I guess the communication technology definitely will help you hire the right person and not sort of have to do with it. But your question of multidisciplinary, Serkan, so again, being an end technology provider, I think we see a shift in having multidisciplinary people at site. So you have someone who's 70-80% they have an understanding of many things, and then when they need to go to that final expert level recommendation, they will get in touch with an expert or even a equipment provider, right? So you need to have a MET who can operate things remotely, who can do a bit of troubleshooting in IT. He knows a bit of mechatronics, he knows a bit of data science. Everyone needs to know data science now, right? You need to be able to crunch a little bit of data yourself. Yeah, so I think that multidisciplinary approach is going to be more accepted, and mining companies will also like that. They can hire a few people who can wear a couple of hats, right? And that is a competitive advantage for anyone, right? Not saying that the experts don't have a place. The experts will have that high level recommendation space, but I think the younger generation needs to focus on broadening their skill set and not probably focusing too much on one. And then when they find something that they like, then sort of specialize.
Yeah. So
Yeah, I totally. Yeah, I agree. I think the technology will help to attract more people in this industry. So, of course, now we don't have to travel to remote mine site. We can just, many engineers can work in the CBD. So you can't tell the difference of those engineers with like IT guys. So they're basically the same. Then this can attract more right people in this industry. And also the mining industry need people from different disciplines, not only from mining school. So from civil, from computer science, from electrical engineering, mechanical engineering. So I think the technology will definitely help us to solve this problem.
Yeah, certainly. I mean, mining industry is currently doing this and trying to do that. But of course, mining engineering knowledge is also important. We see that the growth in the postgraduate studies in recent years for interdisciplinary graduates are starting learning about mining and attending our mining masters and PhD programs. So coming back, Rajiv and Ritz talk about the data. How much data we need? What is the meaning of data when we talk about? So the lots of data we generate in mining industry, and generally we don't know how to use it.
Yeah, it's been my ongoing pain when I'm having a discussion with clients. So general rule of thumb when I'm providing solutions to clients, because I mainly specialize in operation optimization, Excel is a good enough tool, and I can add value to mining operation, say 80% of the value just by looking at 20% of the data. That's because you have a experience and you understand the topic, and you looked at this data a number of times, so you can sort of rapidly focus on that data. But there is a place for looking at the large volume of data when you want your system's fully optimized and you want to really push that, I would say, the I'm calling the dynamic constraints, right? And you want to, for example, if there's a bottleneck in your flow sheet, how do you make decisions upstream where you can maximize the value of an operation? So for that, you need big data set to look at. Ultimately, it all comes down to what your resource definition. A lot of the times you've got a handful of drill holes and a few metallurgical grades and assay samples and or hardness values, and you designing a plant based on that, or you're operating based on these handful of data samples. So if you can increase that resolution right up front in your, say, the mine, whatever is coming into your process plant, you can reduce your operating cost. So in terms of data, I mean, it depends what it all comes. I would say it depends.
So Ritz, what it
Yeah,
depends.
it depends. So look, how much data do you need? Look, like Rajiv, I smiled when he said, his bane when he talks to customers. So suddenly there's this uptake, companies want to say that, oh, we're a big data company, we just want to collect everything, right? Again, I've had conversations with CTOs who's like, I need every point of data. I was like, what are you going to do with it? We haven't decided yet, but we just need to create the infrastructure so that we can collect all the raw data. Okay. So look, there's a pressure. I acknowledge that pressure. Our approach is this. So we've been doing control systems, like very close to what Rajiv does. We've been doing control system for a long time. If you can solve a problem using first principles, right? Like there is an equation somewhere in the world, right? Like flow of water through a pipe. I mean, if you have a pipe diameter and pressure, and length and so on and so forth, you can inference what the flow rate is going to be. As compared to that, if you just want to measure the flow over a whole year and then predict the flow, yeah, you can still do that as well. But is it going to be more accurate than an equation that is already defined around flow? So it is for things. But okay, on the other hand, if you have a camera looking at the grade of ore coming in and you're trying to predict, what's the texture of it, what's the hardness, how much mineral may or may not be there. If you're looking at that sort of things, which is very difficult to define mathematically, yeah, then approximation statistic modeling makes sense. You look at a year's worth of data and then you can find trends. So yeah, I have to default to what Rajiv said. It is for what you want. But my recommendation is, and this, we did this study. Data is not cheap, right? So you think that an Amazon or an Azure, I'm not plugging any names, but any public cloud, right? The cost of actually, the cost of sending data is not cheap. You might look like it's so many cents per data point sent, but if you start pushing large volumes of data, it's actually expensive. So our recommendation is to clean it at the edge. So once you know what you're looking for, have a mechanism to clean it at the edge. Like Rajiv said, I don't want everything. I only want the 20% data, or do your data cleansing, data sorting, and the first three things that a data scientist does it, do it at the edge. Cleanse your data, prepare your data, and then send it to your cloud system so you get the best of both worlds. So yeah, have some sort of a system in place to do smart sorting at the edge and send it up. So how much data do you need? Depends on the application, Serkan. But I think from experience, you can do with a lot less, and get the results.
Yeah. Also, Rithin, I think more importantly, you need to make sure your instrumentation is working, right? And that's, I mean, if you go to any operating site, do I trust the data? So you can collect the data, that's fine. Do I trust it? That's another question, right?
Absolutely. Like get your basics right. Yeah, no point in taking your blood pressure with a broken blood pressure meter. Like it's useless, right? So get your basics right for sure. Yeah.
This ties to my next. I mean, sorry, Binghao. Yes, please go ahead.
I think I agree with that. So we are all talking about big data, but actually I prefer smart data. So that term probably reflect more accurately about what we need. In the simple instances, like we measure the underground temperature. You don't want the rate of 100 Hertz. It's unnecessary. But for inertial measurement unit, you probably need 100 Hertz or even more, even higher. So yeah, it really depends on the application. But the whole trend is we are having a large amount of data, more and more data. And that's why, say for using LiDAR point cloud, it's very easy to be over gigabytes. Without this technology, we don't need that much data. But when we apply this technology, we have to cope with big data. And in the era of data-driven decision making, I think the trend is more and more data will be collected and used. So the bandwidth of the communication is critical. So that's what I'm thinking.
Does that mean we are chasing precision rather than accuracy? I mean, precision is.
Well, so that's a big question. I think what we need eventually should be accuracy, right?
Yep.
So precision is cannot reflect the word accurately.
Yep.
It's good, but you know, it ties up to my next question actually well, and I think is a technology, we can also describe technology as high tech leads to convenience. We also see a lot of examples of overuse of technology. Justification of implementing new technologies are quite important, and we need to ask an important question: why do we need the new technology? Some technology is necessary, some good to have it. And so how do we define the necessity of Internet of Things technologies? So we can start. Rajiv?
I need to think about that. Maybe Binghao can start with that one.
Yeah, Binghao, you said that you know, you want to combine artificial intelligence and IoT. So I know that you also talk about AIoT. It might be a new term.
That's not my term. I noticed people are starting using that term, AIoT. Yeah.
So, but how much technology we need? Do we really need high tech always?
Well, I think it still depends on the application. Like, we'll say use the initial measurement unit as an example. So it can be very cheap, like a few dollars you can buy a small module, or it's over like $600,000. So like it can be used for the missile, so you know, so military usage. And the small one probably is enough for some small tourists, right? So it depends on the application. We need to choose the right one.
Correct. Well, what is the right one? How do you decide the right technology? That's the most important thing.
Well,
so
yeah,
what are
that's well,
because
they will need a lot of you know, so the end users and the engineers, so they sit together to discuss what kind of thing they need.
Yeah, look, I mean, it's really important, and we collect all of these data, and you know, we apply the technology, we implement the technology to understand and use this technology, use this data. So, I mean, so how important to apply this new technology, because this new technology, especially the communication technology, have a lot of collateral impacts to operation, right, Ritz? So what do you think about, you know, what is, for example, Yokogawa's approach on the collateral impacts of technology to the business you apply?
Would you be able to clarify what collateral impact means, Serkan?
So when you apply the technology into an operation, especially in the mining industry, mining operation, the technology applied also can create other changes in the operation. You know, for example, when you do the fully automated mines, you may need to change the whole system, maybe the mining method, maybe definitely the communication technologies you need to implement with the fully automated system, plus maybe the size of the mine, the tunnels, etc., and the roads.
Yeah. Look, you know, the impact of technology. So I guess I'll go to how do you choose the technology. Look, one of the things I'd really encourage is to look outside the industry, right? And I guess for us, you know, we are not a mining only company. So, you know, my role is basically the reason why my role has been created as an industry leader is so that I can look at other solution that Yokogawa have done in other industries and bring that to this industry, right? So that is one of the things that the industry should do. But I also am a little bit of a so my basic nature is I like new technology, right? But you cannot just take technology for the sake of technology. You have to prove return on investment. Yeah? Return on investment is the #1 driver. And you just mentioned, Serkan, that miners love to first to be second, right?
First to be second, yeah.
First to be second. But you can, for example, I'm just picking up one. So blockchain, everyone likes this word blockchain. Oh, it's amazing. It's but they associate blockchain currently only with cryptocurrency and investing. So only the people who know crypto know blockchain. What if, you said, okay, it's a fully autonomous mine, but to make a critical set point change, the autonomous vehicle is going and you want to make a critical set point change. That command from an operator to the vehicle, if it was secured by blockchain, you know that it can't be hacked, right? So that is where you looked at banking and crypto and you said, look, the fundamental need of blockchain was the fact that you cannot hack that command. You cannot disrupt that chain of command, right? Okay, that's what I need to run my mine autonomously, because I don't want I don't want a competitor or a vandal guy crashing millions of dollars worth of a truck by changing its course of direction, right? The GPS signal coming into the truck can be hacked to make it go 2 points left and it falls down the cliff, right? So it comes down to return on investment, obviously, but sometimes it's very difficult to sit and imagine, the scenario. So the advantage is to look at another industry, not necessarily mining, critical industries. You can look at parallel industries like banking, DocuSign, like this technology that we're signing contracts now. If it was 5 years ago, no one would sign a document on the computer, but now due to COVID, you can't go and take a printout of the document. The need as well, the need of the day has pushed adoption of technology. So do we go after every tech? No. You have to prove return on investment. You have to prove the business case, and if there's no strong business case for it, it can wait. And if you can't think of a business case, you have to look at other industries. That would be my recommendation. And again, partner with vendors, especially who have done work outside of mining. Say, hey, look, has this problem occurred in another industry? Yes, it has. How did you solve it? Okay, all right.
That's important.
It's spot on what you mentioned, Rithin. It's driven by the need, right? Like COVID forced us to rethink how we're going to provide a service. Just like I explained earlier, where the guys at site now wearing these visors with cameras and goggles to it, so you can actually see what, as an expert, it's forcing us to change the way, because there's a need for it. I mean, just like if autonomous vehicles, if safety becomes paramount, we're going to change. I mean, we have to change.
Exactly.
Safety has always been the thing. Like if you think about wearable technology, Rajiv. So so over this period, 2 years, we had to do remote testing using wearable devices, right? Sorry, Serkan, you were saying something?
Because there is a question regarding that exactly from the audience. I want to read that. Maybe we can continue with that. So Ian Wolf asking, are government regulations on safety and liability are keeping up with industry developments? That's exactly the question. So we were talking about, you just gave an example.
Yeah, so for example, wearable technology. So an industrial version of a regular Fitbit, right, which is monitoring human parameters like their heart rates, the ECG, moisture levels and stuff. Now I can't see why are we not deploying it currently into mine sites for workers. I mean, it's a no-brainer, right? If their critical data is being sent and the OHS officer is looking and say, hey John, your water levels look really low, mate, can you go and have a drink of water?
True.
Right, that is paramount, but we don't do it yet. It's like, oh man, no, we have a good OHS health and safe policy. We put stickers on the lunchroom. We put stickers on the urinal saying what level of color your urine should be. Yeah, okay, so that's there, but you can solve it with current technology. So it'll take someone to do it first, and then it'll be it's a no-brainer, right?
But many of the technologies we apply in safety is generally it's been developed in mining because of the necessity, all these monitoring technologies, etc. So Rajiv, did you want to say something? Did I cut you? Or?
Yeah, no, I fully understand. But that again, it's driven by government regulations, right? Say, let's take for example Sweden or Finland, the Scandinavian region. They're everything is high tech, fully autonomous, and sensors, that's why Metsu and Autotech. I'm not mentioning names, but that's a lot of the high tech sort of development, right? And likewise in the US as well, and there's not so much in the mining industry, but the other industries high tech sort of developing, right? And it's driven by the government regulations. They're having as soon as you have heavily regulated and incentivized motivation, say, okay, I need to protect my workers. People have to change. You have to adapt to the circumstance. But if you're looking at a mining somewhere, I mean, the challenging regions like Asia or Africa, it's a totally different perspective, right? Now, you don't want to have Fitbit sensors everywhere, but you need to, in that case, you need to empower the workers. You need to train them and upskill them. So it needs to change and adapt.
Exactly. So look, I just want to prompt this, and if you got questions from the audience, please write it through in the chat system. I can see that. So there is one interesting question, not directly related to what we're talking about, but I think it's sort of related because we can define technology. I always tell the students technology means that doing something differently. So that's also another definition. So one question comes from Sujata. So he's really wondering about the biomining. So do you think that we can really apply biomining in the future? And do you think that the people can, upgrade the skills in the biomining? So considering Rajiv, Ritz, you got the processing technology experience. Any comment on that?
Yeah, I'm looking at biomining as I'd say alternative option. Right, it's less energy intensive. There are a couple of places. I think there's an operation in Turkey they're using biomining. I think. I need to find out what. So I looked at it recently. Yeah, I mean, it's biomining is considered because it's a lot more cost effective and less energy intensive process. And just like, there's other technologies available like coarse particle flotation or ore sorting. But I think that's a totally different discussion rather than the context of this
look,
talk.
I mean, Sujata, I can say that, look, if you want to attend the Future Mining Conference, upcoming International Future Mining Conference in December, OZMM organized, which I chair, and Rick's also in the organizing committee. So we will have some discussions about biomining. We got some papers to present. So I want to highlight another important point that we haven't touched actually. I think we all agree, I guess, on that. One of the biggest challenges of mining is social acceptance. Do you think that a fully connected mine can improve social acceptance?
Definitely. So yeah, I would say about 10 years ago, I worked with the university, I think it was University of Sydney. There was a professor there who developed, back when he was back in South Africa, where AIDS is fairly prevalent. So what he did was he used mobile network, 2G network, to capture data. So you walk around with the mobile phone and you go to a community and you fill in a question on a text message, and you send a text message so he knows exactly where you're sending it from. And so you collect the data to make more of like decisions on, okay, what type of medication you need or diet changes for. This is mainly for AIDS, right? The same application can be used for environmental impact assessment. So normally from a mining industry, when you have a community surrounding it, you rely on experts to go and measure environmental proxies like water quality or air quality surrounding, say, a tailings discharge. So the idea was, what if you can empower the community with some very cheap mobile or sensors, right? So in essence, so if you have one mobile phone, one sensor, that's one data point. But if you empower the whole community around that, say a mine site, you empower them to be part of the community, be part of the solution. If there's a high contamination in one particular area, they can feed the information to the mine site. So the mine itself, it's becoming a part, not just a company, standalone company. You're part of the community. and its impact, it has an overall benefit in the community as well, upskilling workforce.
Thank you. Look, there are a couple of questions popped up, and Ian Williams asking, how do you see design of experiment used with AI, OT, data evaluation? Binghao, any comment on that? How do you see? Can you see the question, Binghao?
No, I can't.
Okay, so let me repeat again. How do you see design of experiment used with AI, OT, data evaluation?
All right, so it's how do you see design and experiment use the AIoT data evaluation, right?
Yes.
Design of experiment use with AIoT data evaluation. I didn't quite get the question. Design the experiment.
So Ian, can you elaborate this? I'm also struggling to understand. And yeah, just continuing, Ritz, can you please give answer on the, how can we increase the IoT technology use? Do you think that it can improve the social license to operate in the mines using the IoT technologies?
Yeah, so I mean, Rajiv touched on it very well. But I recently happened to hear it was more of a business talk, but there was this comment on a new type of investor called a social investor. So the younger generation, let's imagine like, the kids coming out of, university, they're in their 20s. When they're looking to buy a share on the share market, right? They're not just looking at, no longer are they looking at just economic performance of that share, right? So they're going to spend their money on something. They're also trying to look at the impact that company itself is declaring that it has on the world. So it might have a great economic performance, but if they don't have any green plans, if they don't have a plan on collecting and doing something, controlling their emissions or doing good to the society, there is now a pressure on these mining companies coming directly from the share market, their investors. So the answer to that question is definitely like collecting more data and showing your impact is becoming, I would say, every CEO's current to-do top list, right? Social license to operate has always been on the top, but now it's like, oh bloody hell, now that's also impacting my share price, right? Because people are looking at how we appear in the market. What is the image of my company in convincing the investors, right, that we have initiatives to save the world. Mining has generally mining has a bad connotation anyways, right? But so there's this big drive. So I would say definitely collecting more data, however it be through community, through census, through other data sources, and then using it to show that this is the impact we're having is paramount, right? Technology will drive it. More than regulation, I think economics will drive it.
But I think there is one question, but I think you just answered it. Can't we digitize the environment, social and economic benefits of mining operations to address the environment, social and governance in mining sector, right?
Absolutely. So there will be like a rating system or something that may come, like we have for our washing machines and other devices. You have a 3-star, 4-star rating system. So taking into various economic metrics, you could start having a metric to say that, look, this company is this star in its in its environmental performance, right? So I think that is going to come soon, and data is going to be very, very paramount in that event. In for those stuff, the more data you collect, the better. So that's where big data will come in. Sure. Emissions, environmental data, soil data, people, health, all that sort of stuff. So no, look, big adoption for IoT in that space.
Look, there is one question which I guess good to answer that. Michael is asking, do you think that in the robotics data pathway moving into the future is going to allow, all-in sustainable costs to be at a point that we will be able to mine more marginal ore bodies? And he's asking what time frame we can achieve this, do you think? Tough question. But easy to answer. You can say 5 years, 10 years, 100 years.
Very soon, yeah. No, look, that's definitely. I mean, autonomous vehicles. Again, Rio sent out this statement saying their use of autonomous vehicles have cut down their operational cost by 30% or something. Like, this is huge numbers, right? So predictive maintenance, another application, of IoT, can cut down a lot of cost. So to answer Michael's question, yes, once your cost has dropped, most definitely you will pursue ore bodies of lower yield or difficult to mine areas. Me personally, I would love to see robots walking around doing a lot of work, completely autonomous mines. Just it's just cool, right? But no, I think that definitely is a driver for
the future. Yeah, I mean, it's important thing. We need to really design fully connected mines to able to achieve this. I guess, as Binghao said,
fully autonomous mine. So even if you lose connectivity, it works, right? And I think that particular topic is driving this other area called space mining, which I'm not even sure where we're at in that realm. But people are talking about space mining, where we're going to other, going to the moon and try to mine elements from remote planets, right? So yeah, definitely.
I think you touched an important point. Yeah.
No, I was just going to say, touching on that. I mean, for example, the Mars rover, right? You don't have real-time connectivity, right? Connection to send a signal and return. I think it's about 45 minutes because of there's only a limit the speed of light can travel at, right? And so, but a lot of the time, the robots itself, it already has pre-programmed, stages what it should be doing. I guess that's, just like Binghao talking about the underground mining aspect. The robot. I mean, if you're still looking at fully autonomous mining, it's the vehicles itself. It's not going to be partial autonomous where it's remotely controlled. Where I think Rio or PHP, they do that somewhere out of their ops out of Western Australia. If you lose connectivity, as Rithin pointed out, that machine needs to carry on processing or carry on. It's. But then you look at the safety aspects, so as soon as you remove people from it, it doesn't really matter. But then you look at the overall value of that asset. How are you going to protect it? You don't want to have a $200,000 or $500,000 truck just falling off a cliff, right?
Exactly. So I mean, we use
probably the point of AIoT.
Exactly.
You need IoT. You need AI.
Yeah.
And the edge computing, all these things.
Yeah. So
I think it's Yeah. Continue, Ritz.
Oh no, look, I just wanted to sort of add to what Binghao said. So we at Yokogawa's current tagline, it's been like that for 10 years, is IA to IA, which stands for Industrial Automation to Industrial Autonomy. So to touch on Rajiv's point, like more than communication, I think the understanding is the more independent the system can be with human intervention once in a while is what everyone wants to achieve, right? So Binghao's term AIoT is also in that space, but autonomy, I think, is what everyone's pursuing, not necessarily IoT, right?
Yeah, look, I mean, we're entering a topic that at least we need a couple of more hours to talk when we talk about autonomous systems or automation in mining, which creates exactly the, another discussion point, which we can't solve within the next 1 minute. So, I mean, there are a couple of questions there, but, we don't have time, unfortunately. If Alex can send us these questions, then we can contact the person asked and we answer the question. If we do it that way, it will be better. So thank you very much for your time, for the attendees as well as the panelists. So I think as a conclusion, digital revolution will continue to drive technological progress. There is no doubt on that. And increasing the knowledge, innovation, exponentially and disrupting all these industries, it will be. So we know that mines of the future, as I said before, must achieve a synergistic cooperation between humans and machinery. with integrated design, planning and operations technologies leading to fundamentals of communications. I again thank you for the panelists and attendees. We had a number of people there, and I thank you to OZMM and specifically Susan, Alex, and Phoebe for the opportunity. And I think its time is up now, isn't it, Alex? Thank you very much for everyone attending.
Thank you.
Thanks, Serkan.
Thank you.
Thanks, Binghao.
Thank you. Cheers.
Thanks, Reggie. Thanks, Reese.